Yeah, good morning. Good morning. Today we'll discuss about the statistical process control. So in the last class we discussed about the control charts for variables. Still we are continuing that the same. Right. So control charts for variables classified into two. Control charts is classified into two things. That is control charts for variables and the control charts for attributes. So we have to discuss about the average chart and the range chart, and then control charts for attributes. There is charts for defective items as well as charts for defects per unit. Okay. So then the charts for defective items, which will be called as P chart, and then NP chart, and charts for defects per unit is called as C and U charts. C and U charts. So these are the charts which are going to discuss in the control charts for attributes. And variable control charts, as yesterday we talked about the in practice control charts are posted and individual missions and work centers to control their particular quality characteristics. And this one and all discussed. So we discuss about the quality characteristics. So here we have talked about the in fact the control charts are used to control the quality characteristics which are not able to under the control. So the variable that is chosen for the X bar chart, the variable that is chosen for X bar chart be a quality characteristic that is measurable and can be expressed in numbers. Can be expressed in numbers. So the quality characteristic which you are going to take is should be a variable which is measurable and can be expressed in numbers. So quality characteristics that can be expressed in terms of the seven basic units. What are the seven fundamental basic units? Is the length, mass, time, temperature, illumination, current, all this temperature, all this will call as a fundamental basic units, and as well as any of the derived units. So from these fundamental basic units, we will be deriving the units such as like no velocity, speed, acceleration, all these called as derived units. Okay, so the quality characteristics that can be expressed in terms of the seven basic units and as well as any of the derived units. So whatever you are going to take for controlling this through control chart, the quality characteristic may be of any fundamental basic units, and those quality characteristics affecting the performance. See which are the quality characteristics that are performance. Those that is will be taken as a highest priority. Means that will be taken into consideration first, and then we'll be moving the establishing the control chart and then monitoring the process This is how those quality characteristics affecting the performance of the product would normally be given the first attention. Next, subgroup size. What is the subgroup size? So subgroup size is nothing but the number of data which are going to collect in a particular sample. That is what you can call sample or subgroup size. We can call it as and the data that are plotted on the control chart. The data that are plotted on the control chart consists of groups of items. That is what we can call as samples. Those groups of items are called as rational subgroups. Means the data which is say at the 8:30 a.m. then the operator is going to collect the data. So 8:30 to 9:30, whatever the data is going to collect as, that is a group of data which is rational subgroup. Okay, rational subgroups. So the data that are plotted on the control chart consists of groups of items. That items means, say for example, in that 8:30 to 9:30 is collected the five observations, five items. So that five items data is grouped into one particular group, that is called as a subgroup, rational subgroup. So which one is called as a rational subgroup? A rational subgroup is one in which the variation within the group is due only to chance causes. So the rational subgroup which is selected should be only it is with the chance causes it should be, and the within the subgroups variation is used to determine the control limits. Means subgroup 1, subgroup 2, subgroup 3, like that. Within the subgroup variations used to determine the control limits, and variation between the subgroups is used to evaluate the long term stability. So within the subgroup, these are the five items which I have taken is used to determine the control limits, and whereas the variation between the subgroups means subgroup 1 2 subgroup 2, then subgroup 2, 3 4, like that, These are all the variation between these groups which will be used to evaluate the long-term stability of the process. So within the subgroup variation will be used to determine the control limits. Within the subgroup variation is going to be used to determine the control limits. This is about the subgroup size. And data collection, how we are going to collect the data, how we are going to collect the data. So assuming the quality characteristics, that is which you are going to measure, so which unit you are going to measure, that is the fundamental units which you have taken. So that one of the quality characteristic which is very important, that has to be taken care. And the plan for the rational subgroups have been selected, means how many items you have to be selected in a particular subgroup. So is it 4 items you have to select, or 5 items you have to select, or 6 items you have to select? That for the plan for the rational subgroups also have been selected. Then a team member means such as nothing but the operator or a technician can be assigned the task of collecting the data, as part of his normal duty, as part of his normal duty. Generally, this how many subgroups I have to collect. So generally, if I want to plot a chart, minimum of 25 subgroups of data is required. It is necessary to collect a minimum of 25 subgroups. Lesser than the 25 will not give you the correct variation, correct picture of variation. And above this also maximum of, say for example, 50, 100 also, that is also good, because it is a numerous data will not be cannot be managed. So that is why ideal number of ideal number of subgroups is nothing but 25 subgroups of data is required for plotting a chart. Now, reserve the collection of data. The technician or team member, such as technician or operator, can be collect the data. And the collection of data is nothing but it is should be minimum of 25 subgroups data. Means each subgroup will be having 5 or 6 items, or 4. It depends on. So totally 25 subgroups, like subgroup 1 to subgroup 1 2, subgroup 3, subgroup 4, likewise up to subgroup 25. We are going to collect the data. So now, after collection of data, what you have to do? We need to plot the chart. After collection of the data, we need to plot the chart for measuring the quality characteristic and monitoring the process. So in this trial center lines and control limits, we can call it as. So trial center lines and control limits. So we need to calculate the center lines, then we need to calculate the control limits. First, center lines are calculated for as a control charts for variable. If you look at control charts for variables, we'll be having x double bar and r bar is the two center lines which you have to take. So for x bar chart we'll be having the center line as x double bar, means average of averages. So x bar itself is just the average of all the subgroups. Average of all the subgroups, in the sense subgroup 1 plus 2 and so on till subgroup 25 divided by 25 will give the subgroup average. So average of averages, in the sense for each subgroup, subgroup 1 will be having the average of x1 bar. Means I have taken the 5 items in a subgroup 1. I have taken the 5 items in a subgroup 1, that is as item 1, item 2, item 3, item 4, item 5. So all these 5 items are added and divided by 5 will give the subgroup 1 average, that is x1 bar. Likewise, for all the subgroups, x1 bar plus x2 bar plus x3 bar and so on plus x25 bar. You are going to calculate for 25 subgroups, each subgroup average. After finding out the each subgroup average, we are going to calculate the average of averages, that is x double bar. So that is nothing but the center line which you are going to show on the x bar chart. So center line you are going to calculate, that is x double bar first. And similarly for the R chart, R bar you are going to calculate, that is average of ranges. Similarly, as I told you that each subgroup will be having the 5 items. In the item 1 to item 5, the one of these 5 values, it will be one will be the maximum, one will be the minimum. So maximum minus minimum will give the range for that particular subgroup. So R1, if I take R1 is the subgroup 1 average and R2 is the subgroup range. R2 is the subgroup range, subgroup 2 range. So likewise for the 25 subgroups, you will be getting the 25 ranges, that is R1 plus R2 plus R3 and so on, R25 divided by 25 will give the average of ranges. So average of ranges we are going to calculate as a center line. So center line for the X bar chart, center line for the R chart we are going to calculate. After calculating these two values, then we will go for calculating the control limits. Then we are going for calculating the control limits. That control limits are nothing but upper control limit for X bar chart and a lower control limit for X bar chart. Similarly, for upper control limit and lower control limit for the R chart, these two are going to be calculated. So next, after collection of the after calculating all this, then we are going to plot the control chart. We are going to plot the control chart based on the previous data. So that is how we are going to plot like this. Plot like this the control chart. Say for example, the subgroup 1, subgroup 2, 3, 4, 5, like 6, 7, 8, 9 like this. We are going to calculate the subgroup ranges, subgroup range as well as average, and then plot like this, and then plot like this. So this is the 25 subgroup data which is plotted like this. So this shows this it behaves a pattern see kind of, but only the subgroup number, say for example it is around 14, which goes out of control, which goes out of control means above the UCL, above the UCL. So first, generally, R chart is constructed first. Then R chart is measured. If there is any deviation in the R chart, that is, any points falls outside the control limits, then we can say that the process is out of control. So this shows that this assignable causes of variation. This point, which shows that assignable causes of variation. So in such cases, then revise, because we cannot continue with the same control limits. We cannot continue with the same control limits. What we do is we are going to establish new control limits. Those are all called as revised control limits. Those are called as revised control limits. How these revised control limits, the control limits which are calculated in the previous manner, this manner, then after plotting the chart like this with the IUCL which are calculated now, with the LCL which are calculated now, then plotted the data. After plotting the data, we will be getting to know that this point is falls outside the control limit. Then we need to revise these same control limits will not be continued further. So we need to revise the control limits. So revising the control limits, what we are going to do is whichever the point falls outside the control limits, that will be eliminated and will be calculate the new revised control limits. So this if I this point is eliminated, then it shows the almost one chance causes of variation only. Chance causes of variation only. So how to revise the control limits? How to revise the control limits? So here the revised control limits. The revised control limits are established by discarding out of control points. Means this is the out of control point. So this point is discarded, okay, which shows the assignable causes, and we are going to recalculate the center line. Once again, after discarding this point, you will be getting the data of 24 subgroups. For the 24 subgroups, we are going to calculate the center line value as well as upper control limit and lower control limit. So then see here, this is how we are going to calculate the revised control. Revised control limits are established by discarding the out of control points with assignable causes and recalculating the center line and control limits. So the R chart is analyzed first to determine if it is stable. If any point falls outside the control limits, that point will be discarded and recalculated the control limits. So the X bar chart now can be analyzed. So after the X chart, then we can be analyze the X bar chart. Next, we are discussing about the state of control and state of out of control. So what is meant by state of control? What is meant by out of control process? So when the assignable causes have been eliminated, when the assignable causes have been eliminated from the process to the extent that the points plotted on the control chart remain only within the control limit, that shows that chance causes are only present. So when the process, when we are going to set the process, when there is only chance causes are present in a particular control chart, then we can say that the process is in state of control. So when the assignable causes are eliminated from the process to the extent that the points plotted on the control chart remain only within the control limit, that's nothing but within the control limits is nothing but only chance causes are present. So chance causes are present, then the process is in a state of control. In a state of control. Similarly, what is out of control process? So out of control, when you are going to say that the process is not under control because it is giving the defective items, it is giving the defective items. So when you are going to say this is the process is out of control, when there is a unnatural variation, exists, then the process is said to be out of control. When there is unnatural variation exists, then the process is said to be out of control. Unnatural variation is nothing but assignable cause of variation. Assignable cause of variation. And also See here, this if you look at, and one more I want to convey to you, the pattern. If you look at the pattern in both pictures, see here, the pattern is shows that it is only a chance bias pattern, very near to the lower control limit here. But if you look at this, there is a points which are 1 2 3 4 all falls within below the center line. So it shows that there is a shift in the process. Shift in the process also leads to a out of control process. Not only that unnatural assignable cause is present, but even though the process which has this chance causes, that is within the control limits, even though it presents with the chance causes, still if the any points falls below this center line, any points below falls below center line, and because up to this point, if you look at this, up to this point the process is moving in a cyclic, a sequential pattern, above and below, above and below. But when it comes to after this point, the points completely falls below the center line, means there is a shift taken place at this particular point. There is a shift taking place, shift moving towards the center line. Center line is shifted to this, means shift in the process is also leads to out of control. And also one more very important lead, trend in the sense, say for example here, if you have started with the points here, it is going in an increasing manner. So here it shows that, they clearly shows that even though these points which are falls within the control limits, it leads to the out of control, it leads to the out of control. Even if you remove this, even it present only from here to here, then the process is said to be, even though it is under control, but because of the pattern exists in the control chart, because of the pattern, which pattern it is existing, it is trend, it is a trend pattern. Trend means either increase or decrease, it is increasing trend. In the increasing trend, we can say that the process is out of control, because it may leads to out of control in the further collection of data. So that's why we can stop this, and then we can control this particular process by taking the corrective action, this is how we are going to do the out of control process. And yesterday we were discussing about this video, control charts for variables. This is how you need to calculate the construction of X bar chart and R chart. Okay. So now the chart is used to improve the process quality, and as well as determine the process capability, and determine when to leave the process alone. When to leave the process alone in the sense, if the process is with the process is within the control, with the process is operating within the control, when the process is operating within the control, then we can say that we can leave the process alone, means as long as it is within the control, we cannot disturb the process, or we cannot go for revising the control limits. And when to make the adjustment in the sense, say for example, if there is assignable cause of variation, then we need to take the adjustments in the establishment of control chart, control limits. So determine if this control chart determines when to leave the process alone and when to make the adjustment. So this statement, when to leave the process alone statement, says that when within the process, within the control, if the process is operated within the control limits, then it will leave the process alone. If the process is not operating within the control limits, then we need to go for adjustments. Okay. Then investigate unacceptable causes of variation. So we need to take the corrective action, right, for assignable causes of variation. Find out the corrective actions, and then you need to establish the new control limits. So if there is any assignable cause of variation, then this control chart will help us to investigate on that particular assignable cause of variation and take the corrective action, and make decisions on product or service specification, and decisions on acceptability of a recently produced product or service, and decisions on the acceptability of recently produced product or service. So we can take the medicine make decisions on the product or service specification, and decisions on the acceptability of recently produced products. Okay. So these are the uses of control chart. This is the uses of control chart, and we'll move on to the next control charts for attributes. Control charts for attributes. So now attribute control charts for attributes. Control charts for attributes. So here, if you look at this control charts for attributes, an attribute is nothing but what, as I told you in the previous class, the variable data is nothing but which measured on a continuous numerical scale, which cannot be measured, but it can be only counted, That is called as attribute data. So an attribute is a quality characteristic for which a numerical value is not specified, and it is measured on nominal scale. It is measured on nominal scale, means good or bad or yes or no, kind of. Nominal scale is kind of good or average or poor, whatever it is. So now, for instance, the taste of certain dish is labeled as exceptions or unacceptable is categorized as exceptional, good, fair, or poor. So the different types of control charts are grouped into three categories. One is, the first category includes that control charts for focus on proportion. Proportion in the sense proportion of non-conforming items, means fraction. This proportion is nothing but fraction of, means if you have taken a thousand items, for inspection, you may get 50. Say for example, 50 items are defective. 50 items are defective items or non-conforming items. We can say it is non-conforming items or defective items, both are same. Okay, so non-conforming items are 50 items, and totally you have taken 1000 items are inspected. So 50 by 1000, 50 by 1000 is nothing but fraction of non-conforming items in a total items. It is a fraction of non-conforming items in a total of 1000 items, in a total of those 1000 items. It means that 50 by 1000 will give 1 by 20. So it is nothing but 0.05. So 1 by 20 is nothing but 0.05. That is called fraction of non-conforming items. Likewise, for each sample, we are going to calculate the p values. That chart is called as p chart. That chart is called as p chart. And similarly, the number of non-conforming items. So if you multiply with the fraction with total number of 1000 into 0.05, it gives the total number of defective items. See, number of non-conforming items means number of defective items. So number of defective items is equal to 50. So how to get 50,000 into 0.05 gives the 50. So PE is multiplied with the number of items inspected, then I'm going to get the NP. So NP for first group and NP for second group, like that you need to calculate. So this is the NP chart. So P chart, NP chart, likewise C chart and U chart is also we have C chart and U chart. So here the second category deals with the three charts that focus on the non-conformity itself. The charts for the total number of non-conformities. Non-conformities is different. Non-conforming units are different. So which in the previous case, non-conforming units I told. Non-conforming units in the sense defective items. Whereas non-conformities means defects and defective. So when you say the defective item, if it contains one or more defects in a particular product, then we can say it is a defective item. So defects are different, and defects is related to the characteristic. It may have the defects in a particular product. It may have n number of defects in a particular product. So that is called as defects. So total number of non-conformity C chart is going to be used, and as well as chart for non-conformities per unit. That is number of defects per unit, means per particular product. That is U chart. So this is suitable for a situation in which the size of the sample is only one. Okay. And in the third category, the chart for demerits per unit. This is we are not using it. We use only C and U, and P and P chart. So these are the four charts in the control chart, variable charts. I mean attribute charts. And in detail, we'll discuss in the next class.